Physical students, today we are going to find a relationship between the volume of a cylinder, it's a right circular cylinder, and the volume of cone. This is also a right circular cone. We know right circular cylinder and cone are those cones and cylinder whose radius vector is perpendicular to their axis, or you can say height. This is the axis of the cone, and this is the radius vector. They have 90 degree, right? Now, very important thing is you can see this cone and this cylinder have same height radius. At the same time, both have same height. Now guys, I can do experiment that I can fill this cone having same radius and same height with the corresponding cylinder with sand. I put the sand into this cone and I pour this sand into the cylinder. One time, two times, three times. When I do it three times, I see that the cylinder is full till the brim with that sand. What does that mean? That means three times the volume of a cone is equal to volume of cylinder. But guys, here it's very important that this cylinder and this cone must have same radius and same height. From this, I easily get the formula for volume of cone. Volume of cone, this is 3 is getting multiplied here. It will be divided here. Volume of cylinder divided by 3. So guys, I got a formula which I will never forget. Volume of cone, right circular cone is equal to, now I know that volume of cylinder I have already understood in my last lecture that for regular objects, the volume is the base area times height. Now the base of this cylinder is pi r square. It is pi r square h. So I fill this value here. Volume of cylinder is pi r square h divided by 3. See guys, you apply the logic and you get great results in mathematics. You love mathematics. Thank you very much. Now comes the next thing is the volume of a what? Volume of a sphere. Now guys, you see that I've got a sphere whose, honestly speaking, radius, this is the center of the sphere, and the radius is nothing but r. Now, initially I was talking about the surface area of the sphere. In the surface area, you don't go inside. You don't see how much space is there inside the sphere, but you are only concerned about the outer area. And I know that the surface area of the sphere of radius r is 4 pi r square. Well, I know this, because I've understood this in my last video. But now I'm talking about, though it's looking 2D, but actually it's like a ball. It's a sphere. It's a three-dimensional object occupying space, occupying jaga in Punjabi, or you can say occupying, volume. The volume of a sphere. Volume of a sphere is basically what? Now it is 4 by 3 pi r cube. Volume of a sphere, is 4 by 3 pi r cube. Since volume is 3D, you see r has a power 3. Pi is constant, 4 and 3 are constant. So my dimensional, homogeneity is also achieved. That the volume of the sphere is 4 by 3 pi r cube. How can I do it? If somebody thinks, how can you do it, sir? So what you can do is basically take a jar, have this sphere, maybe a small sphere, fill this with water. Fill this jar with water and put the sphere in this. When you put the sphere in this, now once again, you must fill the jar till brim, completely with the water. Now when after filling the jar with the water, put the sphere. Some water will overflow. Collect that water. When you collect that water, and then when you see the volume of this water displaced, the sphere comes inside. As a result, the water goes outside. So obviously, whatever space this sphere has occupied in this jar, the same water has been displaced outside. So the volume of displaced water would be equal to volume of the sphere. When you measure this volume according to this, it will come out to be same. So guys, volume of sphere is 4 by 3 pi r cube, and volume of cone is 1/3 of the corresponding cylinder. So what is the volume of cone? Cylinder volume is pi r square h divided by 3. To see more interesting videos like this, when you join your day-to-day experiences with your mathematics and physics, log on to our YouTube channel, Learn CBSE. If you really like it, do not forget to share with your friends. Thank you.